Hello students, welcome back. So in this session, I'm going to be talking about histogram. Let's say you have this data right here. This could be somebody's score, this could be somebody's height, this could be somebody's test result, could be anything. So histogram is a visual tool, and what it does, it converts these raw data, it converts these raw numbers into a shape that helps you see the data, understand the data. It is a tool to perform univariate analysis. Univariate means single variable analysis. And what histogram does, it groups your data into bins, and the height of each bar in these bins, they show the frequency or density of your data. So these are some of the applications of your histogram to check frequency or count of data between some range. So let's say you want to see you in this particular instance, let's see you have 51. Your data is going from 51 to 75. So since your data is going from 51 to 75, let's say you want to check. You want to know how much of your data is between 60 to 65. So histogram allows you to visually see that, like how much of your data is between 60 to 65. Histogram also helps you identify if your data distribution is normal, skewed, uniform, bimodal, and so on and so forth. So it basically helps you. It helps you in how your data values are spread across different intervals. It also allows you to compare multiple groups. So let's say you have two schools and you want to test, you want to see how these two schools are doing in terms of their scores. So histogram allows you to compare multiple groups. It also allows you to compare variances of two data. So for example, to find which of the two stock is more volatile or riskier, you use histogram for that. It also allows you to detect to find your outliers, anomalies. So, for example, if you want to detect fraud in the banks, now I'm going to plot this histogram. Okay, this is my data right here, and I'm going to plot the histogram. My histogram will look like this. Okay, this is my final result. Step one, first you decide how many bins you want. In this case, let's say I decide to have 8 bins. So my bin width it would going to be maximum value minus the minimum value divide by the number of bins. Well, my bin width, my range actually starts with 51, right? It starts with 51, goes up to 75. So my range is going from 51 to 75. So my bin width is going to be maximum, which is 75, minus minimum, which is 51, divided by 8, and the answer is 3. So I'm going to have bins with each width. Okay, the width of my each bin is going to be 3. Okay, now let's calculate step number 2. Now you are going to calculate the edges, the bin edges. You start with 51. That's the first thing you do. You start with 51, and you already know your bin width is 3, right? So you add 3 to that. Okay, and you get 54. Then you add another 3 to that. You get 57. Okay, and you just keep going like this. 60. Okay, keep going like this, and these are your bin edges. Now you know your bin edges. So this is how I came with these numbers. 51 right there. Okay, these are my bin edges. 51, 54, 57, 60, 63. So each one of them is basically incremented by 3. It starts with 51. Okay, this is where it starts with, and it ends at 75 right here. And it ends at 75 because if you remember my range right here, okay, it's from 51 to 75. Okay, so my bins are going to be from 51 to 54. Okay, that's my first bin. So from 51 to 54, but remember, you do not include 54. Okay, this is excluded. You include 51, but do not include 54. The next bin is going to be from 54 to 57. You include 54, do not include 57 in it. From 57 to 60, you include 57, but do not include 60. And you keep going like this until you reach the end. Step 3 now is from your data, okay, find your bin counts now. So for each bins, these are my bins right there, and for each bins, find your count. So let's look at this one right here, 51 to 54. Let's see how many elements are there in 51 to 54. Well, you will go on top, just go on top right here, okay, just come over here, okay, and just count. Well, you only have one. From 51 to 54, there is only one right here. This is it. So count is equal to 1. This is how I came with count 1. Okay, now so once you know your count 1, this now you do the next one. Okay, 54 to 57. Let's do that. Well, 54 to 57, remember you do not include 57, so it's going to be 55, 55, all these elements right here. Okay, this is my count. So in this case it's going to be 5, right? There are total of 5 elements over here. Okay, so this is how I come down now, and this is how I came with 5 right here. Okay, this is my 5. Then you do the same thing. Then you calculate how many numbers are between 57 to 60, but do not include 60. Well, go on top again, count from 57 to 60. So this right here is from 57 all the way to 60. But remember, do not include 60. So this is my right here. These are my numbers. And if you count them, your answer would be 11. So there are 11 of them. Come down, and that's my 11. And you can keep going like this. Okay, and this is how I'm plotting these numbers. So my 1 right here, okay, that tells me how many elements are between 51 to 54. That's my 1 right here, okay. 5, okay, this refers to how many elements are between 54, okay, between 54 and 57. 11 right here, it refers to how many elements are between 57 and 60, okay, and I just keep going like this. So this is how I came with 11, this 19, and 26. And this is how these this histogram is plotted. So histogram, they have some applications. So let's try to see some of the applications of histogram. What are the uses of histogram? So first one is like histogram, they help you in identifying. They help you to identify the types of distribution. Just by looking at that, you can tell what type of distribution that is. So let's look at this one right here. So this is my plot. Okay, I did a histogram, and just by looking at this, you can tell that this is a normal distribution right here. Okay, the normal distribution had a characteristics of a bell-shaped curve. This one right here, okay, this one is a skewed distribution. It is not a bell shape. You can see it's a skewed distribution. It's actually going like this, right? So generally, these are your skewed distribution. More specifically, this is a right skew distribution. Likewise, there's also a left skew. Left skew curve will look something like this. It's going to be like that, and it's going to go like that. Okay, this would be a left skewed curve. Okay, then look at this one. This one actually is pretty much uniform. So this is a uniform distribution because look at this. All your bars right here. Okay, they're pretty much uniform. They're pretty much constant. Okay, they're not changing too much. So they don't have this normal curve, and they don't have this skewed either. Now look at this one right here. This one is actually is bimodal, and the reason it's bimodal because of two peaks. You see, this is the first peak, and this right here is my second peak. So that's why it is called bimodal. Then this is another example of histogram, another use of histogram. So this one actually helps you compare multiple groups. So for example, let's say you have two class, okay, and you know the exam score for class A and class B, and you have plotted the histogram. So this is the plot for the exam scores for two class A and class B. So just by looking at this, you can tell that your class A, okay, class A, which is your blue curve right here. This is your class A. Okay, this is my class A, which is a blue curve right here. Okay, it is centered around 75. You can see the mean value is 75. So if you come down right there is my 75. Okay, this is my 75 for my class A. This is my average value for class A, and you can also see they're tightly grouped. So see this one, okay, is a tightly grouped. Okay, you can see it's the values are not much spread. Okay, look at this one. Now look at class B. Now compare this with class B, which is an orange curve, which is this one right here. Okay, this is my class B. Now, if you look at the average of class B, your average of class B is around 65, right? 65. So if you come down, it's somewhere over here. This is my 65. So this is for my class B. This is my class A, okay, and this is class B. So class B has a lower average, and also you can see the look at the spread. Okay, look at the spread of your class B. It has a high spread. Okay, so it has more spread. Your class B has a more spread. So this you can determine. You can figure this out just by looking at it visually. Okay, and now histogram also allows you to compare the variance of two data. Okay, that's another interesting example that it allows you to compute or compare the variance of two data. So let's say you have two data. Okay, this is my first data right here. Okay, and this one is the other data. And if you look at it, this tall curve right here, okay, it's very tightly packed. Okay, this all clustered together. So that's what it's telling you. When you have a data like this, it's all tightly packed. So basically, that tells you this one has a low variance. So this data has low variance. Okay. This one, on the other hand, is not very tightly packed. It's basically spread. You see, this curve is basically spread like this, all the way like this. So this one actually has high variance. Okay. This one has a high variance. So this allows you to actually understand like which curve has a more variance, which curve has a high variance or low variance. Although both the curves have the same median, okay, sorry, the same mean value, the mean is same, but your variance is different for these curves. Okay, now histogram also helps you detect outliers or anomalies. So let's look at this data right here. Okay, this is my data right here. Okay, and I plot the histogram for this, and it looks like this right here. Okay, so this is my histogram for this data. Now I introduce two outlier over here. So I changed these two numbers. I changed 72 to 75, and made it to 110 and 100 just to show you. So when I change this data, and I now I plot the same data on histogram right here, and you can see my curve has changed. Okay, and you can see because of those two values, because of these two guys right here. Okay, you can see because of these two guys, oh, right there, because of these two guys, your shape has changed, and it has introduced this little bump over here. You can see it's going like this, then there's a little bump. So anytime when you see these little bumps towards the end, that's a sign of an outlier.